I guess.
I could. But for reasons I'll get to in a minute, that probably wouldn't work out so great in the way I've showed you guys so far. All right, so to back up here for this recording, we are looking at how it is we can use the source dimension start attribute and source dimension end, which is to say, if a matrix is fed into the jit.matrix object, how does the jit.matrix object read it? Does it read it? Well, by default, it just reads it from the beginning to the end, as we have here, but we can change that. And to flip it upside down, we simply reverse these numbers. So 159, start on the right side of the movie, and then go to 0. And so this is the mirrored image. And then 119, start at the bottom of the image, and then go to the top. So that would turn it upside down. And we see some weird things happen if I don't do that, right? So as I was doing it, we saw, well, what if I just read one line of the y values? Well, that's going to look stranger because now we're not reading those. We're just getting two rows to read. So what I said we would do is to turn the image right side up again. There we go. And try to zoom in on this portion right here. So I said that's about 3/4 of the way over. So we'll say we'll start at 120 and go to 159. And then let's say it's about 3/4 of the way up. So we'll just kind of locate it here. So we want to go to 119 and we'll kind of zoom. Oh, it's the wrong way. Kind of like that. I think I zoomed in on that particular part of the image. It's kind of hard to see because it's pixelated. Smooth it out. All right, or if we wanted to try to zoom in on a particular point, we could try to fudge it this way. So that's about all I want to say about that, because to me, there's a better way to do stuff like that. Although these sort of effects where we're stretching the image like this are kind of interesting. And like I said, you will see this sort of thing repeatedly in other examples. But to do the same sort of thing over here, we have our jit.rota object. And remember the jit.rota object rotates or offsets. So it can spin the image around at a certain anchor point. Here I put the anchor point in the center of the image, so it would spin around that axis. So put it in the center and spin. You can also offset, that is shift it left and right like we looked at last time, or we can zoom in. So if we shift our anchor points, we can zoom in to different points, I believe. So here we look at a zoom factor of 1, and that is, come on, that is normal. And then as we move in, right, we zoom in this way. And since we looked at how a matrix does this, you can imagine that that's kind of what's happening under the hood here, right? Is that we can do the same effect this way or this way, right? So if we wanted to isolate a certain point, we could do that. This zoom function is pretty interesting in that what happens if I go this way, right? And here, depending on the bound mode, different things will happen. So let's explore the different bound modes. So a bound mode is an attribute of rota. We can get that attribute with a true, an attribute UI. So here's bound mode. Most of the time I prefer to just use messages, but we can do this. So let's change this to 2, one of my faves. And here we get sort of a tiling. So if you've ever worked with screensavers on Windows or something like that, it used to do something like this, where you could choose what happens if the image is too small for the screen. We'll just repeat it. And then if we shrink way down, we get sort of interesting images. This is a lot of chickens. The different bound modes, like this one just clips or it crops out. If the image is too small, it just crops to black. This one will kind of smear it, I believe. Yeah. And then, number 1, as we showed, number 2, as we showed, has this effect. And then there's also numbers 3, which has this effect, which is pretty interesting. So it kind of takes the last pixels and pushes them out. So that's an effect. And I believe that's, I guess number 4, oh, we have kind of a kaleidoscope with number 4. So creatively speaking, these are useful to make sort of interesting patterns like this fairly easily. All you need to do is just make your zoom such that the image no longer is as big as it needs to be to fill that window, and the rota object will perform these sort of tilings or different manners of placing the image onto the window. Okay, so there's that. Remember that we can rotate this, so I'm going to put this back to 1, and this would be the same as what we just did before to turn the image upside down. Here I've just rotated it by pi. So if we think of our sine wave as something that goes up to 1, which would be like 90 degrees, right? So it goes to 90 degrees and then to 180 degrees. 3.14 is 180 degrees. So we've just flipped everything 180 degrees. This would be the way I prefer to do it. It's theta 3.14 as opposed to having to figure all that out with the source dimension start and the source dimension end. Okay, so I just wanted to cover that one little thing here for the purpose of showing you that these things exist, the source dimension start and the source dimension end. There's also a destination start and end if you just wanted to send parts of the matrix that way. But honestly, it's not something that I use ever, or I haven't found a reason to yet. Okay, any questions about this before I move on to something else? That was a brief moment. Okay.
So you said we wouldn't use this kind of window in like performance, right? But we could use these functions well with the performance window, right?
Sure, let's do it. So here's jit.window. And so here we have a small window, right? And I can just run anything I can run to a P window, I can run to this window. It's the same thing. Right, so we'll show that it's basically the same thing. And then the common thing to do here is just to go to the help file. And right over here, there's this little full screen, press escape sort of thing that you just copy and paste. And let's look at it briefly just so that it's not total magic to us. Inside this patcher, it says use the key object, which will get any key press you make, and take the, what is it, the ASCII code. And if the ASCII code equals 27, which happens to be what the escape key is, then we're going to send a bang out. And when we send the bang out, it says go full screen, and then we hit escape again, it turns that off, and we're not full screen. And there are many other settings we can change to not show the mouse, to not show the menu, all those sort of things. But for now, we'll go full screen with this. But before I do that, let's automate a little bit. So we'll do a counter that counts to 100. And we'll divide that by 100, so we get numbers between 0 and 1. And we'll feed this into our zoom stuff. We'll leave the bound mode in this sort of kaleidoscope mode. This is a Q metro, and I'll run that at some rate, 60, let's say. And remember that 60 means 60 of these will come out in a second. So is that right?
Can you remind me, please, what's the difference between Q metro and metro?
Metro runs on a different scheduler. Q metro goes to the back of the line, like a British Q. So the reason we use this, we could use metro. The effect would be exactly the same. It's just this is a little safer when we're dealing with video things. They're not as time sensitive as audio things. So if this were for musical timing, this would be a bad idea. So this would mean my quarter notes would not be, it would be like it's played by a middle school band, right? So what's supposed to be 1 might come out right like that. That's what the Q metro does. It's just not quite as exact. But for this purpose, it doesn't matter because we won't see that. All right, so there we go, and I'll press escape to get our full screen, and it's horribly pixelated. It looks like what I might have, looks better than what I might have programmed on my Atari 800 when I was a little kid. Fun. Okay, so yeah, so normally we're not using P windows if we're actually going to do something. We don't want to show our max patch necessarily on the screen. We just want to show this, but for quick working purposes, we can do just a P window. Okay. Let's just start a new one here. So what I'd like to do is I would like to look at how do we work with videos to first do something like simple combination of videos. So let's take the following thoughts. Like I have this file somewhere. Anyway, so let's first we're going to create a crossfade between 2 videos. Second, we'll create a fade to black. Third, we'll create a fade to white. This should be somewhat review for you if you've read the tutorials, which I highly recommend that you do. There's a lot of tutorials this week, by the way, but they're all really easy and short, so don't panic. I think you'll not have any problems with them. All right, so how do I crossfade between 2 videos? Well, first we would need some sort of video, and I do recommend just using jit.movie or jit.movie tilde. Jit.movie tilde will allow you to get the audio out of the movie. I would say that's probably a decent choice, but it won't work unless you have the audio on. So let's just say jit.movie. And our attributes for this are something like a bunch of stuff, like auto start, on or off. Do we want the movie to start immediately or do we want to press play? I'll say, well, let's just let it do immediately. So I'll say auto start, 1. And I'll say adapt 1. So I don't need that. There's one thing I do like about this is the unique command. I recommend this. It's not often covered, but the unique command, if I turn it on, so off is 0 and on is 1. If I turn it on, what it does is no matter how many times I send a bang to this movie, it will only output a unique frame. So it's computationally more effective. We don't send out multiple matrices for a movie if we don't need to. So for instance, right now, if I load in a movie, so let's take one with sound. Garbage, is that the right one? Yeah. I'm going to put this in holding down the Option key, and that gives me a message box option to just read in this movie. So if I do this now, I think even if my audio is off, it's going to play the sound of this movie. But nope. Okay, so what's happening now is that, let's see, P window. The question is it playing the movie now or not, right? And I said start, so I'll just send 1 bang to it, and another one. So my thought is that it's probably playing this movie right now, right? So if I say start to it, it should be playing the movie, but we are not seeing the movie play because it needs bangs to show it. This is the wrong one. I wanted demolition. Where is that? This one. Crash test, it's called. Okay. There we go. So as you could hear that, right? Okay, so as we hear the movie's playing, right? Even though we don't see anything coming out. So let's put the jit.p window here and just prove that we don't see anything. And I'll turn the volume up again. So the movie's playing, but we don't see it, right? So that's a good thing to recognize, that this movie is, you know, it's playing. But unless we send bangs to this movie object, it does not output the matrix. So we will do a qmetro here. And I don't know the frames per second of this movie, but since I have the unique command on, as long as I go fast enough, it won't output duplicates, which is what we want. So short of the long, good to put @unique1 in your movies. There we go. So now we've got the movie playing back, and the goal was to crossfade between two different movies. So we will repeat this process. We'll use the garbage movie. And we don't need to start. I'll take this one, put it here, read in the garbage movie. We'll send it the qmetro as well, and we'll see it in a P window. There we go. So we will crossfade between the crash test and garbage. How do we crossfade?
Using the alpha channel?
We could use jit.alpha blend, but for now I'm going to use the more generic, and because jit.alpha blend will only work with videos, right? So I'm kind of wanting to be a little bit more generic, so when we move on, if I wanted to crossfade between arbitrary matrices, it doesn't matter what they are. It doesn't matter if they have an alpha channel. So I can use jit.xfade is our best choice here. So jit.xfade can crossfade between two matrices. So I'm going to go between this one and this one. And right now we don't have any crossfade amount, so we only see the demolition movie.
Is there any issue of sending the matrices out of the outlet on the P windows themselves?
I tend not to do that because eventually I'll eliminate these P windows from my patch, but it's probably okay.
Okay.
But these are computationally expensive, so if I start making a performance patch, I don't actually want these P windows if I don't need them, so I tend not to do that. Right, okay, so how do I crossfade with the crossfade object? And we need this attribute or this message, crossfade, and the $1, which remember that the $1 means I don't know what that value is yet. I'll tell you later. It's an argument. So here we go, and we say as we crossfade between these two things, there we go. We go from one to the other. I can crossfade them.
You also just automate that with like a line object?
That is a great question, because that was what I was about to do. So let's look at how to do that. Remember that we do line, and it's important here that we tell it that it'll be a floating point number, a number that is not an integer, but one that has something after the decimal point.
I do have a question.
Yes.
I can see only 2 movies there. I'm assuming you can do more movies. Can you put a argument in jit.fade for more movies to put in there, or can you only do 2?
Well, because it's kind of a, if you think about it, how would you crossfade in a triangle is kind of an interesting question. You cannot do that. You would have to have an additional jit.fade, and then you could fade in another movie to blend in with these two. Right, so then I would take this and a movie like, let's take the basketball guy here. Whoops. Let's take the basketball guy. And we gotta grab this metro. And we'll put it in this side. And we'll use the same sort of crossfade logic. Oh, gotta turn the volume down. This is why I sometimes like using the jit.movie tilde object, because it has outlets for the audio, and I don't hear it if I don't hook those up. Okay, so we've got this all ready to roll, and now we will see the crossfade now between this set of movies and now the basketball guy. So there we go. So you just have to have another crossfade. Crossfade the crossfaded image. Okay. So the line object, remember, takes a message and it says where do you start and where do you end. So we will start at 0, and putting a comma there, remember, makes a new message. So that's one message all by itself, which tells the line to just pop back to 0, and then we will go to 1 over 5 seconds, or 5,000 milliseconds. There we go. And I could hit it again if I wanted to. That's pretty simple, right? You can crossfade between two movies this way, combine two movies in a way that is fairly simple. The next goal, right, is to crossfade to black. So I'll keep this little bit of logic here, but I want to get rid of this movie. So you guys tell me, how do I crossfade to black?
You have to have another matrix that's just all black.
That would make sense, right? That's probably the best way to do it. So jit.matrix, let's say it's, how do I do this? I can name it, right? Black.
You'd want it to be the same dimensions probably as the first video.
So 4 planes. I'm not even sure it matters because it's black, but you're right, probably should. So we say character, and then I don't know what it is, so I'm just going to say 320 by 240. What did I do?
That you spelled matrix as maxtrix.
Good.
Yeah.
Like Matrix, bro.
That's the next external I need to make. Jit.maxtrix.
But
Okay. Yeah, so now we have this matrix here. And the question is it already black, right? What do you think?
It's probably just nothing. There's no color defined.
Well, let's take a look. So we'll look at jit.cellblock. And let's send plane -1 here. And by default, it just fills itself with zeros. So it is black already, but let's be a little more explicit about it. And how do I set every cell here to be 0 in all planes?
Set cell.
Kind of. So we do set all, and we'd say 0. So the way you would figure that out, right, is you would go here and say, which messages do we have? And we see set all is there. And you might say, well, that's likely to be the case. If I didn't know that, again, we can go to the reference and we can look and say set all cells to a value. Set all cells to a value specified by the value or values. Position is specified of a list whose length is equal to the number of dimensions. Okay, whatever. So set all to 0. So there we go. This is all going to be what it is.
Could you also just like clear it? Wouldn't that
Yeah, because it'll go back to default, right? Zeros.
Would the alpha being at 0 mess things up though?
No, it's just kind of ignored because we're not blending the alpha. So we don't see the alpha. The alpha is only used if we're doing something like alpha blend. So it won't matter. So now we can fade from the demolition, the crash test to black, right? And we can use our crossfade here to make such. All right, that's pretty easy, right? We just use a matrix, and so the pedagogical goal here is to remind ourselves that a matrix is the same as a movie. A movie is a matrix of pixels. How do I make a white matrix?
Set all to 255.
Yes. So I will set all to 255. And
Wouldn't that mean that the alpha channel is also set to 255? I guess it doesn't matter.
yeah, it doesn't matter though. It only matters when we want to blend those alpha channels. That's what alpha channels are for. Is they're really like a crossfade themselves. But like I was saying earlier, I actually don't want to use the alpha blend object here because this crossfade object is more general purpose. And later when we get to, let's say, crossfading between two positions in 3D space, then the alpha blend doesn't even make any sense anymore. But crossfade still does. All right. So now, now that we've done that, what I want to do next is I would like to crossfade the signal that's going in with the output fed back. And you wish you could do this, but you can't. So there's a technique for doing this. We'll make a jit.matrix. I'll call it feedback. FB. Well, I'll call it feedback. And I put the output here. So let's set this back to 0 for a second. And the thing about matrices is, remember that I can refer to this matrix just by calling it by name. So if I just copy this, now this matrix, right, is the same as this matrix. So whatever this feeds, because it's named feedback, whatever this gets it's automatically here. This is the same as this. So now I can plug this into here. But this isn't outputting anything yet. So I could hit one bang here. There we go. And now it's kind of going, right? But what I tend to do to make sure this works is to just send the metro here. Okay, so now what are we doing? We are taking the output of this and feeding it back to the other side so we can crossfade between the current frame and what was the past frame. And that has this sort of look, right? Where we start to blur a bit. So the equivalent for audio, right, is like a feedback delay. But we're not really able to control the delay time here. We're just gathering frame by frame. And if I set this fade time to something really high, then basically the feedback frame starts taking over a little bit. And if I go above 1, then it's probably just going to stop, right? Now all we get is the feedback. And the feedback goes, it's just the same image. So this makes probably the most sense, either to go crazy and go way above this and get weird results, or to just stay beneath 1. All right, so yes.
Could you use pipe to delay the stuff coming from the matrix, the feedback, and that would cause a different delay time?
I'm not sure because it delays numbers, lists, or symbols. Yeah, like a matrix is a kind of list. So let's see, pipe, pipe, initialization list. I guess I'll just put a delay time in. I think I can do pipe, I don't remember, pipe 1000, does it take milliseconds?
I think so.
At delay time, I like that better. There we go. And we will try to run this matrix into the pipe and see if we can get a delay. And how will we know? Let's see. I can't really tell if it's working. Whoa. Here we go. I don't know. I can't tell if that's working, so I'd have to really think about what's going on there. I guess the best way to do that would be to look here. Yeah, and it looks like it's just killed it.
Is there no JIT equivalent of pipe?
Well, So yes, there is. To answer your question, you would do this with matrix set. So that would give you a set of matrices, kind of in a book. If you want it, like if a matrix is a page, then there's a book of them, and then you would read out what you collect in the book at a later time. Okay, so since I've made this little hole here now, what's kind of interesting to think about is what would happen if we were to put something into the feedback loop, right? And now we're starting to get into sort of what John Whitney's analog machine would do, because it was able to take multiple pictures on a single frame. So it's kind of like feedback. So let's put the jit.rota in here. And we will put just an anchor X. And now I'm needing to know more about this movie. So I'm gonna assume 160 is the middle, and at anchor Y 120. And now I really need to know more about this movie. So how do I know more about the movie? Because I don't know the dimensions of this movie. So let's find out how we know. Query. Frame calc. Get time. None of that really helps me. Sizing. Frame dump. I've done that before. Sizing, clear, get movie dim. There we go. All right, so this is the message we send to the movie to understand what the movie dimensions are. They are 320 by 240, so I was correct. So I'm going to set my anchor in the middle of this movie. And I'll go ahead and just give it a theta of, let's just say, like, just rotate it a little bit, right? So let's think for a second about what's going to happen here. So every time this goes through, right, it's going to get rotated. So it's going to spin without me having to spin it with theta, because it's going to rotate a rotated image and then rotate that rotated image again, and then rotate, rotate, rotate. So let's see the result. Fade in a little bit here. Yeah, now we get this sort of interesting thing that reminds us maybe of John Whitney. Now, John Whitney wouldn't have used a movie like this. He might have made his own set of dots, right? And we have to remember that we're also cropping here, so remember that we have the bound modes we can play with. So let's take a look at number 2 here. Number 2 looks like this. Or we could try number 4. And then if we choose to zoom, right, we can put a zoom value into our rotation. Let's see what that looks like. Right, and now it's kind of getting crazy, and we can change our bound mode again and kind of see what's happening there. Oh, these are interesting shapes. Okay, so probably best to be dynamic with this zoom. You know, kind of change it occasionally so that it doesn't just drift into nowhere. And don't forget our last bit of the rota, not really the last bit, but the last thing we've talked about, which is the offset. So what John Whitney said his analog computers do is to rotate along different axes. Well, we're not going to do that. We're just going to rotate this way. And he also said that he was able to shift the image along. So I'm just going to offset along the x-axis. So offset x 1. So it'll move a pixel. I should really do this to be a little more clear. 1. It will move hopefully along the x-axis. So now it should be shifting in some way. Let's see if we can make that a little more extreme. And we'll change the bound mode here. Whoops, I lost everything. All right, so now things are strange, and we could change our anchor points and so on. So now, we've gotten much more into a non-representational sort of world of, interesting figures that are mathematically derived, as a matter of fact. And in fact, in much the same way that Whitney was doing it. So when he talks about, in his interview, which you will hopefully watch this week, he talks about using polar coordinates with his digital system that he had to work with. That's a fancy way of saying this, right? So he's basically changing the angle and the magnitude of something. So the polar space is in a circle, as opposed to the Cartesian space, which is not. All right, interesting. So now we want to be able to maybe crossfade between a normal image and that image. We've already got our crossfade in. There we go. And this image is looking a little bit less than colorful. So in the spirit of those early animators, let's examine how we might change what we have here to be more colorful. How would we do that?
Use the jit.op object, multiply colors into it.
Maybe so.
Or
maybe
add colors.
Yeah, let's try that. That's not the way I was thinking, but that is a legitimate sort of thought. So jit.op at op pass the alpha and then plus pass. So we will have red and green here at val. These are character matrices, right? So I think I can just add 128. And so now what's coming out of here, we'll try to add some color to and see if it works. Oh yeah, there we go. We get some yellow. Well, that's neat. But I think what I want to kind of have happen is I would like for it to maybe, when it's, I guess I can multiply it. I can multiply it, so when it's black, it's a different color, and when it's white, it's another color. So let's do multiply. So we still get this black characteristic. Oh, I forgot to. That's interesting that happened.
It's bluish.
Huh. I guess. Yeah, that's weird. So that's one way to do it. Another way to do it is to this thing that we saw a little earlier that I kind of swapped through is this jit.charmap. So map characters. So now this is something that's built to do what we're trying to do here. So we're going to map colors onto this black and white sort of image. So let's look at the help file. And here we go. It's doing this, and it says, oh, I can change what the red is and the green is and this is. So let's see if that'll work. So let's say jit.matrix lookup. They're doing a lot of weird stuff here. I don't know why they, oh, I see. They're filling the lookup with this. Seems kind of complicated. So I think I had another one that I was working with that was easier. Yeah, so I just chose to do this. Oh, it's a big mess. All right, so here, we'll just take what we need out of here. In the true Mac spirit, we'll just steal stuff. What am I crossfading? Okay, I was crossfading in some chickens, as one will do. All right, here we go. All right, so I have some objects here that we haven't covered. This one is called Swatch, like a Swatch watch from the 80s. And it outputs this stuff. Some floats, right? So here we've got so much, I think this is actually an RGBA. So we have so much red, green, blue, whatever. And we have to prepend a start to this. So we're going to start and end for this gradient object. So the idea here is that we have to start and end. I feel like I'm supposed to be seeing something, so let me bang out the result here. So here we do the gradient starts at red and ends at green. And I say, okay, we'll take that then and map that maybe onto this black and white image. Yeah. And so then we get something like this. And that's a little bit too much for me. It's really bright and kind of saturated. If only there was something that I could change the brightness, contrast, and saturation with, or something like that, right? Or maybe I could just change the scale and the bias of these colors. I could do all of that. So let's look at two objects that do that. So one is called brightness, contrast, saturation, Bracosa. Adjust the image brightness, contrast, and saturation. So let's take the output of here. And then let's look at what we've got. We've got these attributes. It says contrast, brightness, saturation. So if we take the saturation down a little bit, we get more toward, gray. Or if we can get it really saturated, maybe I like that. And let's grab another one. Let's grab the brightness. And I will turn down the brightness a bit. Oh, I'm liking that better. There we go.
What is saturation actually doing to the image?
That's a great question. I don't know the answer off the top of my head. I kind of think of it intuitively, like saturate. So I imagine it's a multiplier upon the colors. And I guess I could prove that by saying, like, well, if we do this, then all the colors go to gray. I'm not sure. I've looked this up before. And if it were true that it was a multiplier, then this would be black. So somehow it's like making them all equal at this point, and then when we go higher, right, it's flooding those colors. So I don't know the answer. Sorry to say. And lastly, we have contrast, which I've also looked up before. And contrast basically tells us how much difference there's. The dynamic range is the best way to think of it. So we'll make a really big dynamic range. So now there's a lot of contrast between these colors. Or we could say there's less contrast, and that also tends toward gray. So I said it was too bright for me, but now I kind of like this color. Maybe I can just turn down the brightness some. I kind of like that. Maybe I just don't like these colors. Maybe I should just use darker colors. Well, that's kind of cool. There we go. So there's my image. So what was this, right? This was this thing up here. But now it's not. And this could be even cooler if we chose to put some sort of zoom value in here to sweep things along. I would challenge you to maybe look at this method of doing things and try not to use a movie like this, but maybe make a drawing yourself and take a picture of it. Maybe just a series of dots. And maybe see, or like John Whitney did with a glass plane, right? Or glass plate, sorry. And see if you can sort of make these interesting geometrical shapes just through rotation and dyeing the colors, as it were. Okay, I think that's about all I want to cover for today. Basically what I've introduced, oh, I did want to do that one other thing, which was jit.scale bias. So jit.scale bias can scale and bias, which means it can multiply and it can add. And it can multiply and it can add on any of the planes. So red, green, blue, alpha. So let's run our Bracosa image through the scale bias now. And this is sort of an easy way to work with the colors. So here's a ton of attributes, but we're going to look at the, let's look at the red bias. So what is that going to do? Well, let's look at the blue because there seems to be a lot of blue in here. The blue bias. So blue bias means add this amount. So there's always going to be some blue, right? So as I add this, there's more and more blue until it just turns all blue because I put so much blue in there. And I think I can shrink down, like, yeah, so take the blue out. So this is just an adder, right? Like add this value to all blue values, the whole blue plane. As opposed to blue scale, which will multiply the blue values by some amount. So here, just reduce them in a scaling fashion. And I can do that for all colors. So let's also look at the, well, let's put some green in. We'll just bias in some green. So even if there's not green in this image, I can add it in this way. Okay. So
how color correction works, kind of?
Yeah, pretty much. Okay, so I don't want to add any more new information right now. I'm going to try to be careful about not flooding the whole information plane by biasing the information plane and scaling it high, saturating it. So we've got these new objects we looked at, which are not quite new. We've already looked at jit.rota, but here we looked at it a little bit in depth. So jit.rota. We examined thoroughly the jit.xfade. And in particular, we examined it with the idea of feedback, which is a very powerful tool. We also looked at how to take a matrix itself. So do I have a matrix? And use its source start and source end dims to be able to just grab portions of a matrix, which, like I've said, I don't really use that very often. And we looked at the following objects. We looked at Bracosa, brightness, contrast, and saturation, and scale bias. And this is a way of changing colors by adding or multiplying, adding and or multiplying. This is a way of changing things kind of in a different way that probably could be done with scale bias.
I have a question.
Yes.
So you can do the like prepend start, prepend end. Is there like top, middle, bottom, so that you could have like a 3-color, 4-color gradient instead of just the linear?
I don't think so. I think this object just goes between 2. But if you wanted to, because what would that mean? You know, it would mean like from the top to the bottom. I see what you're saying now. Let's see. Yeah, I guess I would try to do that in a way we looked at much earlier, which would be to rewind a bit. And this is kind of awful, but we have this jit.expr thing. And that allows me to use sort of math formulas to generate how things go in 2 dimensions. So this gradient is kind of one-dimensional, right? And this would allow me to make things in 2 dimensions. So if you want to explore that, you can. And I'll give you a brief reminder that there's this norm. 1, for instance, would put things from 0 to 255 across the red plane. And then I could also do, you know, norm somehow. Norm 2 would put things from, I'm sorry, I said that incorrectly. Norm 1 would put things across the x-axis, the y-axis, and norm 0, sorry, x-axis and the y-axis, right? We get values. So you'd have to explore this a little bit. And the help file is right there. So generalized normal, and then you can do all these interesting sort of things. But that's actually a really good question. Like, how would I make a 2-dimensional gradient that I could somehow use? This charmap isn't going to take. I don't think it wants. I don't know what it's going to do. I could put the chickens in there. So let's do it. Let's create a movie that plays it. and we'll make another crossfade, and we'll crossfade the gradient with the chickens. And now that's going to be the thing that changes the character map. And we will need the X fade value. And we will need
and the
to
metronome to bang
make
it.
our chickens go. Okay, and yeah, there. That looks pretty cool, right? Those are chickens. Chickens in a car crash. It looks like a weather map. And, you know, now I'm starting to sort of build a sort of system, right? Which I'm going to have a lot of parameters to play with. And, you know, at some point, just to give us a preview, even though I said I wouldn't introduce any new information, I can't help myself. So, you know, we have these ways of getting sound in. And then we would be able to maybe take the average of the sound. And scale that. So what goes from 0 to 1 might go, yeah, we'll just keep it 0 to 1. Maybe we'll smooth it. So slide, whoops, at slide. Oh, I can just do it this way. 100 and 100. And if I turn my audio on, and if I drag in some music here, some audio, how about, yeah, sure, little Stravinsky. And then I can take a snapshot every so often. So let me get that metro again. Right, so now I'm getting the values here, and then I can say, well, maybe it would be fun to change the crossfade here. Right, and now we get a little more dynamicism in our image that correlates with a sound, so easy DAC.
Audio is not shared on our end.
Oh. I guess it's worth it. It should. It says share sound. Oh, yeah, right. Sounded good to me. All right, there we go. We'll try it again. Now we'll hear it. And who knows if that's synced for you? I mean, probably not over Zoom.
It looks pretty good.
All right, so there it is. So let me, this is a gigantic mess. I think I'll clean it up and post it to the folio so you have access to it. And let's look at folio and just be clear about what you're doing this week. There's a lot of tutorials, like I said, that I want you to go through, and I do very much recommend that you go through them. These jitter tutorials are not quite as involved sometimes as the MSP tutorials and the Max tutorials. They kind of just do one thing. So I looked through them and I said, this is totally doable in a week, in a day, in an hour, maybe. All right. What is my password? GameStop something. Okay, and folio. We're in week 3 already. All right, so all of these tutorials, this is an optional one. We've done it so much that I just don't think it's necessary. In fact, we've done most of these things. The controlling movie playback is kind of important because I haven't really talked about that. But you can slow down movies, play them backwards, play from different loop points. It's all right there, and it's not hard. We just send different attributes specifying those parameters to it. The simple mixing and more mixing we've also done, but it's worth looking at. So they're fairly simple and a large part review, but I would like you to go through them just to pick up the little bits that we don't cover in class that might be in there. And then the other thing I'd like you to do is just kind of explore. So the best way to learn stuff like this is to just kind of try stuff. You know, work with this feedback thing. See if you can come up with something cool. Like I said, maybe you want to draw something yourself and take a picture of it and then put it in to the software. Maybe you want to work with the real-time camera input if you can figure that out. That's not hard. So just explore some things. You know, if you can create something interesting, we can look at it in class next week. But that's really the trick, is to spend time doing this, to become interested enough that you actually do it. If you don't do it, then it's really hard to just learn from listening to me in class. You have to kind of experiment yourself, and it's a very wide-ranging terrain to explore. So we won't be able to cover everything, but I'll try to cover the things that I use often and that I think are fundamental and useful. Okay, any questions about what you're supposed to do? There's nothing to turn in this week. You are free to not turn things in. It would be cool if you had something to show next week, but if you can't come up with anything interesting, then there's no consequence for it, except my silent disdain. What a terrible thing to say. All right, so stuff to share.
The worst of punishments.